we are doing a very interesting and a very important sum. Let's see this. It says prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. Now here, what are we supposed to draw? Which you have already seen there, but why it is drawn that way? Let's understand. Prove that the sum of the squares of the sides of a rhombus. So we need to have a rhombus first. So here we have quadrilateral ABCD, which is a rhombus. Rhombus means all the sides are equal. So we write there quadrilateral ABCD is a rhombus, right? Then it says that we have to prove that the sum of the squares of the sides of a rhombus, right? That means the two prove is the sum of the squares of the sides of a rhombus. Now, which are the sides? So it is going to be AB. So for that we write AB square plus, sum means plus, so plus the next one, that is BC square, plus the next side, that is CD square, and the next one, that is AD square. So sum of the squares of the sides of a rhombus is equal to, so we write is equal to the sum of the squares of its diagonals. So we need to have the diagonals there, that is we have the diagonals, that is BD and AC, and they intersect at point O. So that should also be written in the given, that diagonals AC and BD intersect at point O, right? And in the to prove it says it is equal to the sum of the squares of its diagonals. That means it is equal to sum of AC square plus BD square. That is what we have. So now a given and the to prove is done. So we know what are we supposed to prove, right? Now let's proceed further. Now if you look at this particular part, that is we want AB square plus BC square plus CD square plus AD square on the left hand side equal to, on the right hand side we want AC square plus BD square. So if we look at that AB first. Now AB belongs to which triangle? It belongs to a triangle, that is triangle AOB. Now is that triangle, in that angle that is angle AOB, is that angle 90 degree? Right now so no. But can it be 90 degree? Yes, it can be 90 degree. You know why? Because remember that diagonals of a rhombus are perpendicular to each other. That is why that angle will be 90 degree. That means now we have it as a right angle triangle. So if it is a right angle triangle there, can we apply Pythagoras theorem to get AB square? Yes. So we are going to do that now. So in that triangle AOB, we write there angle AOB is equal to 90 degree. Why 90 degree? Because we know that diagonals of a rhombus are perpendicular to each other, right? And now we apply Pythagoras theorem, we'll get AB square is equal to AO square plus BO square. So we write that. Was this easy? And this is by Pythagoras theorem marked as result number 1. So what we are saying is we wanted AB square, we got it, right? But on the right hand side we want AC square plus BD square. But here we have AO and BO. AO square plus BO square, right now. So that means I don't want AO, right? So now what else do we know about the diagonals of a rhombus, right? Because we want AC and BD. We know one more thing, that they are perpendicular. At the same time they are bisecting each other. That means now if they bisect each other, what can we say about the length of AO? Length of AO will be half the length of AC, right? And same way, what can we say about the length of BO? It is half the length of BD. And these are the two things which we know. And that is what we write. AO is half of AC and we write BO is half of BD. The reason for both would be nothing but because diagonals of a rhombus bisect each other. And that will be your statement number 2. Now it's very easy further. Now these are the things which we know, right? We know the first statement is AB square is equal to AO square plus BO square, which we got. And the next two are nothing but your statement number 2. Now the job is very easy. Somehow we just need to substitute the value of AO and the value of BO in that statement number 1. Let's do that. So now the left hand side of that statement number 1 would be AB square is equal to. Now the value of AO, we are going to substitute that. So let's substitute that now. So here we'll write it as half of AC, the whole square. Plus now for the value of BO we are going to substitute now. So we substitute that there. So there we would write it as half of BD the whole square. Beautiful. And we got it from where? It is from 1 and 2. Now we just need to solve it further. So the left hand side would be, we get AB square is equal to, on the right hand side, half of AC the whole square will be written as what? It is 1 upon 4 into AC square. Plus the next one, it would be 1 upon 4 BD the whole square. So it is 1 upon 4 BD square, which we got. Easy. Simple. Now, you know that on the right hand side the denominator is nothing but 4. So 4 goes on to the other side, right? So that means we'll get 4 times AB square is equal to AC square plus BD square. We got this too. Easy, simple. Now what has happened? Now just compare this with what we wanted to prove. On the right hand side we wanted AC square plus BD square. Have we got it? And on the left hand side we wanted AB square plus BC square plus CD square plus AD square. But what do we have? 4 times AB square. So 4 times AB square, can we write it as AB square plus AB square plus AB square plus AB square? Yes. And that is equal to the right hand side. That is AC square plus BD square. Now let's compare. Right? This is which we have marked as result number 3. Now let's compare. AB square we got. Right hand side may we want AC square, we got that. Right hand side may we wanted plus BD square, we got that. That means only the missing things are BC square we want CD square and we want AD square. Instead of what? AB square and AB square. So that means, is there a relation between AB, BC, CD and AD? You know that AB, BC, CD and AD, what are they? They are the sides of a rhombus. And what do we know about the sides of a rhombus? We know that they are equal. That means we can write AB is equal to BC is equal to CD is equal to AD, which will be a statement number 4, and the reason is sides of a rhombus. We just need to substitute these values in that statement number 3. Instead of AB, AB and AB, we write there BC, CD and AD. So now we would get the result as, we'll get AB square plus BC square plus CD square plus AD square is equal to AC square plus BD square, and we get it from where? We got it from 3 and 4, and our proof is done. Was this easy? Simple, right? Very important.